Okay, ladies and gentlemen, let's get on with this review guide here. So, smallest particle that still retains the properties of an element is an atom. You have to have all the particles there, otherwise it doesn't act like an element at all. This number right here is the atomic number. This number down here is the atomic mass, not to be confused with mass number. If I round this into 12, then it's a mass number. Okay, what is the overall charge of the nucleus? Well, let's think about this. What does the nucleus have in it? It's got protons, which are positively charged, and neutrons, which are not charged at all. So what is its overall charge? Its overall charge is positive. Why do we use the atomic number to identify an element and not the other subatomic particles? Well, if I change the number of neutrons, it's still carbon, right? If I change the number of electrons, it's still carbon. It's just an ion of carbon. But if I change the number of protons, it changes the element completely to something else. That's why, because the atomic number is the number of protons, and that is what identifies an element. Okay, electron, the symbol is E minus. Location around the nucleus. And its relative charge is negative, minus. Relative mass is 0. And it determines the ion. If I change the number of electrons, all it does is change it into an ion. Proton, the symbol is P+, is located in the nucleus. Its relative charge is positive. Its relative mass is 1 AMU. And it determines the element. Neutron, symbol is N0 and naught, located in the nucleus. Relative charge is 0. Relative mass is 1 AMU, and it determines the isotope. Okay. Equals the atomic number. Number of protons equals the atomic number. Electrons equals, if it's a neutral atom, it could be the atomic number or number of protons. A equals P equals E in a neutral atom. Mass number minus atomic number equals neutrons. Chlorine 37 has how many protons? Well, if I look at a periodic table, and I look at chlorine, I see that its atomic number is 17, therefore it has 17 protons. Why is atomic mass not a whole number? So all these numbers here are atomic masses. Why are they not whole numbers? Because it is the weighted average of all the isotopes. And because of that, it's not going to be a whole number. It's going to be a decimal. If the number of protons change, then the element changes. Protons don't change, though. I mean, they can, but that's a different discussion. But If I add a proton to carbon, if it's got 6 and I somehow add a magical proton, it's now nitrogen. It changes the element. If the number of neutrons changes, then the mass number changes, and it's called an isotope. What is the mass number of oxygen 18? God, I hope everyone got that. It's 18. What element has 7 protons and 8 electrons? Well, if it has 7 protons, it's definitely nitrogen. But if it has 8 electrons, what's it charged? It's got 1 more electron than proton, so it is negatively 1 charge, so it is that, N minus. An atom with 9 protons, 9 electrons, and 10 neutrons would have a mass number of 19, because mass number is protons plus neutrons. What is the charge of a nitrogen if it gained 3 electrons? Well, if it gained 3 negative charges, that would make it 3 minus. The correct isotope name for oxygen with 10 neutrons. Well, in order to name that, we're going to have to know its mass number. In order to know that, we have to know that it has 8 protons. 8 protons plus 10 neutrons is 18. Therefore, this is oxygen 18. Or oxygen 18 with an 8 down here, right? Okay, same number of protons, but a different number of electrons is called an ion. That's what all elements do to try and get, whoa, there we go. There we go, oxygen 18 or O with the 18 up top and an 8 on bottom. That's the atomic number, that's the mass number, or just oxygen with the mass number. Same number of protons, different number of electrons is called an ion. Isotope with the highest percentage will have the greatest effect on average atomic mass. Isotope with the lowest percentage will have the least effect on average atomic mass. Okay, so this is the mass number. This is the atomic number. This is a mass number. Hopefully everybody understands that in isotopic notation, what they have to give you in order for you to know the number of neutrons it has is the mass number. So both give you the mass number. You have to have that to know how many neutrons it has, and that's what differentiates each of our isotopes. So sodium 24 has how many neutrons? Well, if it has 11 protons, then it has 13 neutrons. This has 12 neutrons. So 13 neutrons, 12 neutrons. That's the difference between isotopes. That's why they have to give you the mass number. Have to. Okay. Okay. I don't like the way some of these are asked, so I'm going to complain about them as I do them, but I'm still going to do them. So, I have to identify the mystery. Well, they've given me a mass number. That doesn't help much. They've given me a number of electrons. Well, I'm going to have to assume it's not charged. So I'm going to have to assume that A equals P equals E. So atomic number equals protons equals electrons in this thing. So I'm basically assuming that it's oxygen. And its symbol is O. And it has an atomic mass of 8. The atomic mass is dead off the periodic table, so oxygen 16.0 might be different on your periodic table. Number of neutrons. Well, if the mass number is 18 and the protons is 8, 18 minus 8 equals 10. And the most common isotope, I have to assume that its atomic mass rounded is the most common isotope, so I'm going to say Oxygen 16 is the most common isotope, whether it's true or not. Okay, so now they've given me another thing, atomic number 6. Well, that makes it easy. It's obviously carbon. So carbon, symbol is C, atomic number is 6. Atomic mass is 12.0. Number of protons is 6. Number of neutrons is 6. 6 plus 6 is 12, so its mass number is 12. Number of electrons is 6, because I'm assuming it's not charged. And the most common isotope I'm going to guess is carbon-12, which it is. Okay. Then they've given me this charged fluorine here. What's the atomic number for fluorine? Is 9. So that's 9. So protons is 9. But I don't have, oh, I have 10 electrons. That's where I get that -1 charge, right? Yes. So fluorine's atomic mass is 19.0. And then they don't give me a mass number, so I'm going to round that into 19 and make that an atomic number. 19 minus the number of protons. 19 minus 9 is 10 neutrons, right? And so the most common, this is going to be fluorine. Fluorine. And it's going to be fluorine 919. And there we go. Oh, and it's negative. -1 charge. Okay, excellent. Now then, we've got some atomic masses. I'm going to stop this video right here, and I'm going to continue on because they don't like loading when they're longer than 11 minutes. So I'll see you in a second.